Okay, so we're gonna have our third conic section here. So, but again, real quick, you tell a parabola from one squared variable, right? You tell an ellipse from two squared variables that are being added, right? A circle is also two squared variables being added, though, right? Okay.
But they're not.
But you have different coefficients with them. If it's an ellipse, you have the same coefficient as a circle. Okay. A circle really is an ellipse. It's just the one where you, well, no, a circle is an ellipse. You're moving in the x direction and the y direction the same amount. Okay.
So can a circle be divided by Can a circle be a fraction?
No, well, you can have fraction coefficients. Yeah, you could have fraction coefficients as long as they're the same.
Okay.
All right, so we're looking at the third one now, hyperbolas. The way to tell a hyperbola is both squared terms with a minus. All right, both squared terms with a minus. Now, because it's a minus, now it does matter what order they're in, right? With a plus with an ellipse, it doesn't matter what order they're in, because you can switch them, plus would be the same thing. With a minus, it does matter, okay? So, the positive one, the positive variable, tells you which direction the hyperbola is going to open. All right, so that does matter, okay? Positive variable tells direction of opening. Alright, so, and these are where you kind of have to draw the box, alright, and you have diagonal tangent lines. Do you guys remember any of this? Okay, well, you make a box. Let's just do an example here. So, let's say we have y squared over 64 minus x squared over 25. Hyperbolas also are equal to 1. Okay. These numbers, the 64 and this 25, they still do the same thing they did with an ellipse. That's going to be the distance from the center that, but in this case we're going to be drawing a box. Okay, so you'll see that here. So first of all, this one, there's nothing in parentheses, so that means there's no shift, right? That means the center is the origin, okay? Yeah.
What is that plus sign mean?
Oh, the positive variable tells the direction of opening. Okay, so which is the positive variable here? The y. That means this hyperbola is going to open up and down. Hyperbolas are basically two parabolas. So it's going to open up and down. Okay, so if it was the x that was positive, it would open left and right. Alright, so we put our center down. Now we treat these 64 and 25. We treat them the same way as we did with ellipses. Alright, from the center, we're going to go up and down 8 in this case, right? And we're going to go left and right 5. Everybody see that? Now instead of drawing an ellipse, we're drawing a box. Okay, a rectangle. We draw a box, okay? From the box, we draw diagonal asymptotes.
That's what I'm doing about that. If it's two parabolas,
They're not really parabolas. They're not really parabolas. But they kind of look like parabolas. But watch, we're gonna draw. See if I can do this semi-correctly. Okay, so we've got. Sorry, I'm running over my type there, but we've got. You draw on your two diagonal. Asymptotes.
yeah. Are they supposed to meet up at the middle?
Yeah.
Okay.
There's one, okay? So now then what you do is you decide which direction you're opening by the positive variable, which is the y in this case. Since the y is positive, we're opening up and down. You start at the edge of the box, okay? You start at the edge of the box right here, and you draw, basically it's like a parabola, but it's not quite the same, but you draw the curves out to the diagonal asymptotes, and then you do the same thing on the bottom.
So those asymptotes tells you where to stop?
It just tells you where to put the curve, yeah, where the curve approaches, yeah. It's not really there. The graph of this hyperbola is only these red curves, all right? The rest of this is just a mess just to help us draw it, okay? Can you graph these on the calculator?
Yes.
Sure, what do you have to do? Solve for y. Okay, you solve for y. You can graph them on the calculator. Okay. Let's just do one more where there's a shift. Okay. Yes.
Oh, never mind. I saw that as a 2, the 8. I don't know. I'm blind. But that was shown after the 2 came from.
Okay. So we're good.
Yeah.
Okay. So let's do one with a shift. Let's look at, well, let's do this. Okay. X minus 1 squared over 9 minus y plus 3 squared over 16 equals 1. Alright, so we're going to sketch this by hand. You guys, all these conic sections really are easier to draw by hand than they are, because to do it on a calculator, you got to do a bunch of algebra first, right, to solve for y. It's actually more work to do that than it is to just graph it by hand. All right. Okay, so first we got to plot our center. So what's our center here?
Our center is
1, negative 3. Alright, that's our center. Alright, so from there we are going, how many in the x direction? 3. So 1, 2, another 3. And that's going to put me right here. And then we're going 3 this way, so 1, 2, 3. And that's going to put me here. Alright, so that's the edge of my box in the x direction. And we're going 4 in the y direction, right? So up 1, 2, 3, 4. It's going to put us here and down. That's right here. So 1, 2, 3, 4.
from y.
From the center. It's all from the center. So you go left and right from the center, up and down from the center. And sorry, it's hard. My graphs always, when I'm drawing low like this, get a little skewed here. Okay, but we're going to draw our box from there. Okay. Just connect the dots. The dots are halfway. The dots are the halfway between the edges of the box. Okay. That's a pretty bad box there, but that's okay. Now you're going to put in your diagonals. Now we're actually not going to do where you write the equations of the diagonal asymptotes for these, but you could. It's not that hard. You already have a point. You have a point in the center that has to go through, and you can figure out what the coordinate of the corner is. If you have 2 points, you can do the equation of a line. Okay, but I don't think I assigned any of those. Now we just have to decide which way this is going to open. It's left and right. So we start at the center here and go up towards that one. All right, and like that. And there's your hyperbola. Okay. Any questions? Whichever variable is positive. X is positive, so it's going to open left and right. If Y was positive, it would open up and down. Okay? You good?
Wait,